Hi, I'm Zulfany. Now we will talk about the maintainability. When we talk about software, we need to know how easy it is to maintain our software. So this is an important case in maintainability because we don't expect 100% perfect when developing a software. So for maintainability, there are also some metrics that we can use. The first one we can look at is the tracking defects. Now, when we talk about maintainability, it means that the software has already been deployed and defects happen as we go along. And so the defect should always be reported. Now, based on this reported defect, we can use this to measure the maintainability of our software. The report should be in the form of like what you see in this slide. There should be an ID, and then they have the description and how to recreate the steps. So all this detail should be reported, because based on this detail, the technical team or the software developer will then try to fix it. And then we can calculate the defect density. So basically, after all the reported was collected, then we know the number of defects found. So we can calculate the defect density, which is the number of defects found, over the size of the software. The size of software usually in terms of kilo line of code. So for example, let's say in our software, 50 defects were found, and the software actually is about 20 kilo line of code. So then I can say that the defect density is 50 over 20, which is 2.5 defects per kilo line of code. So it means that for every 1,000 line, we found 2.5 defects. That's not bad. So that means we can fix this defect, and it shows that maintainability is high. Another metric we can use is the mean time to recover. Now, whenever we found a defect, this defect should be fixed, and it takes time to fix this defect. So mean time to recover actually is a metric to measure that, which is mean time to resolve all of the defects divided by all the total number of resolved defects that we get. So let's look at this example. Let's say in a time of 2 weeks, a development team tracks how long it takes to resolve 10 bugs. So that means the average time taken to resolve the problem is 40 hours. And the total number of resolved bugs is 10. As mentioned before, we have 10 bugs and it needs 40 hours. So then the mean time to recover is 40 over 10 is 4 hours. So that means the average time the development team takes to fix an error is 4 hours. So then you should have a threshold defining which is good, which is not so good. Another metric we can check is the open and close defect. Now, when we reported the defect, if it hasn't been handled at all, then it is still open. If the defect has been handled, then we mark it as closed. So to check the maintainability, we need to understand how many open and closed defects do we have. Because basically, if maintainability is good, we expect we don't have any open defect. All defects should have been fixed. So they all should be closed. So if we have a lot of open defect, that means probably it's not maintainable, our software. Not so good because it's difficult to fix the error. A maintainable software means that it is easy to read the code, it is easy to fix problem. And how do I get the information? Well, in the beginning, I mentioned that you should track the data, and you can get the summary of the data stating which one is still open, which one is already closed. Another metric for maintainability we can see is reopen defect. Now, let's say a defect has been fixed. It's already closed. But then we found that it is not properly fixed. So we need to reopen the case, reopen the defect. So this is what we mean by reopen defect. So the reopen defect rate can be calculated from the number of reopen defect over the number of the resolved defects times 100%. Here's an example. We are monitoring our software, and then the total number of defect resolved was 40. But actually, there are 6 of them which is reopened. So that means the reopen rate is 6 over 40 times 100%, which is 15%. So how to interpret this 15%? It means that for 6 of those defects, the bug fixing was not properly done. That is why it has to be reopened. So in this case, this 15% means that the bug fixing was not properly done 15% of the total bug. So this also tells you maintainability, how good it is to maintain, because basically if maintainability is high, it should be no problem fixing anything and should not be reopened. If it's reopened, that means bug fixing was not properly, or perhaps it is caused due to difficult to maintain. So improvement should be made for your next project. So thank you for today. I'll see you again in our next meeting.